is an expert out there, I push everyone to Mark because he is amazing at it. And what I love about 3D printing right now, and this is why I think we have 62 people on there, is the price point and accessibility is getting better and better every year. And so it's an exciting time, not only just to learn the technique, but the problem solving that goes with it. And that's what as you think about your project, think about it not only from the how to, like getting kids knowing the software and whatnot, but the how to apply this to a much larger youth development situation of problem solving and design that you guys can use in your programs, because that's what's exciting about 3D printing. And with that, I'll turn it over to Mark, who you can see in his on his coffee table has amazing products already out, and the 3D printer's going.
I think this is the first time for any of these presentations I've actually been able to get my printer on here. So I'm going to try and share my presentation here. I hope everybody can see that. So thanks again to Dave and Gabby for having me here. I always love talking about 3D printing. It's a hobby of mine. I've been doing it now for going on about 8 years, and kind of to follow up what Dave said, there's been a lot of advances in 3D printing in the past 10 years that have made it a much more consumer level type of technology that can be used, and the educational opportunities with 3D printing, and not only the 3D printing, but the 3D modeling are so significant. There are science applications, there are math applications, design, engineering, art. It's a true STEAM activity. And when I think about STEAM, you're integrating art. There's no better activity to me than doing 3D printing and 3D modeling. It attracts the engineers while also attracting your artists at the same time. So when you can get engineers and artists, the creators at the same time together and talking about and excited about the same thing, I think that speaks to the just power of it, and just speaks to what you can do with it in the applications. So I've been teaching 3D printing and 3D modeling for about 8 years. I've 3D printed more things than I can count. So this is just a little bit of a layout here of things that I have done. And there are so many more things that I just haven't done that just, if I were to find the time one day, I'd love to do. But that's always one of those nice things about 3D printing. You'll always find something else to do. So what we're going to talk about today is just, first of all, the basics. What is 3D printing? What options are out there? One of the questions I get asked a lot, oh, Mark, I'm into 3D printing, but I don't know which printer I want. So I was like, okay, well, let me touch on that. What is 3D modeling? What's the big deal? Because really, when you talk about 3D printing, it's great to have the printers, but if you don't have the models, if you don't have the ability to make the models, you don't have the ability to teach youth how to learn what the process of 3D modeling is, you lose the real education, the real purpose behind it. So there is we're going to talk about 3D modeling, and I'm going to show the options for that, and then go through about how Tinkercad specifically is such a great option. I'm not going to go into the depths of just how to use Tinkercad, because I'll share some documents I've already created to help with that, but just ideas for how you can use Tinkercad. And then again, some of the big pieces about what you can get out of 3D modeling in the process. Then I'll just briefly touch on how you take 3D models from that, turn them into 3D prints, and then more. And yes, just for the record, or whenever you see these images here, it's just a little capture of, yes, this is an actual model. This is something that somebody has modeled, something that somebody has printed. There are people that wear 3D printed sunglasses and glasses in general. There are so many applications that we're going to touch on that some may never know of, and some are literally being innovated day by day. 2021 has already been a huge year for 3D printing. So it just constantly is evolving, and it's constantly becoming more and more relevant in our everyday lives. So a very basic introduction. What is 3D printing? Well, it's what we call one type of an additive manufacturing process. Now, what is additive manufacturing? What that basically means is you're building something. That's just the engineering term for it. Additive manufacturing. You take an object and you build upon it layer by layer. If you can see the 3D print going on now, and if you've ever seen a 3D printer before, it builds an object by basically making layers of the shape of the object and building these layers on top of each other one by one until the entire surface is created. What is actually being built right now is an Eiffel Tower shaped cookie cutter. One of the very first 4-H projects or programs that I did with 3D printing is we did a Christmas themed 3D printing workshop where the youth used Tinkercad and a program that no longer exists called Cookie Caster, and they made their own cookie cutters. And yes, they do work because on the first session, they made them. So this particular 6-year-old made an Eiffel Tower shape. And then in the second session, we actually took the cookie cutters and made Christmas cookies with them. And yes, they worked. And so again, it's another theme where it's like, hey, you can integrate, it's an artistic element. You can make it something seasonal. We also had another one where they created their own Christmas ornaments. So I always like to tie it into holidays. They make great gifts to create 3D printing, objects for people. So, but 3D printing has so many applications, but it's not something that's new. As I said, it's only been in the past 10 years that really, like us, the common people, have really been able to do a lot of stuff with it. It's been around for about 40 years. So it's nothing actually new. But again, the innovations come with how fast they move, the price points, the types of materials they use. There are 3D materials that are wood. So you can have actual 3D print things in wood. You can 3D print things that stretch. So you can actually create 3D printed stress balls. You can create, metal infused things. So you can create 3D objects that rust or objects that you can sand. They have all different types of 3D materials now that are called exotics. So basically the most common 3D printed material you'll find is called PLA. So that's what most of the stuff here is printed with. That's what is usually recommended with kids because it's safe, it smells good, it's all good to use, and it's basically broadly available and broadly usable across the board. There are other types of 3D printable materials that you might come across, but basically all you need to know is PLA is the most common, most widely available, most widely used, and it's the one I recommend you start with. And it's also the cheapest. So we'll talk about costs in a bit, but that's the cheapest option. So PLA is the one to go with. So again, speaking briefly about 3D printer options, because this is probably the most common question I get about it. My recommendations always go to the same place. They go to Prusa, which is the orange one to my left, and they go to FlashForge. Those are large 3D printing companies. Basically, a 3D printer that you get, they vary in size, shape, capabilities. Usually, yes, the more expensive they are, the more capabilities they have. But again, the big piece that's happened is that they've come down in price so much that it's actually something that can be afforded by more people. So for example, the 3D printer on the left, which is my Prusa Mini, which is the one I use the most often, has a base price of about $350. So it's a good intro printer. It's user-friendly. It has the built-in touchscreen. It prints very fast. And I, in general, like the company Prusa. They're based in Norway, if I remember correctly. They're the top-selling 3D printer in the world. They're the most reliable. This thing is never broken, and it's literally fallen on the ground in the middle of the night while I've let it print something. I've have many 3D prints on overnight, but very rarely have I had a 3D printer that which has actually toppled to the ground, and then the printer has not only stayed in place, but the print finished successfully. That's a sign of reliability to me. So the Prusas are always a recommendation in terms of which 3D printer to go with because they're just that sturdy and they produce wonderful prints. Most of what you see here has been printed with my Prusa. So the Mini is their small model. That's the smallest price, as you can see there. Another good one is called a FlashForge. And again, there will be links at the end of these where you can get these later, so do not worry. FlashForge is also very common. They have a few different models, different sizes, so available on various different websites. Again, price points, again, in that $300 range, which is pretty good. Another one is your Monoprice here, which is, again, even cheaper. They're not quite as large, not quite have the same kind of capabilities, but still a nice printer. And if you are price conscious, your Monoprices are the way to go. Most 3D printers have the price is determined by the size of the bed. So basically, how large is the thing that you can print? If you want to print larger things, you're going to have to pay more. If you want to print things faster, you're going to have to pay more. Makes sense. So this has a very small build plate, as you can see. The Mini, the Prusa has about a 1 foot by 1 foot size build plate. This is about 1 foot by 6 inches, a lot smaller. So it means you can print smaller things. So But when you're doing introductory 3D printing sessions, and especially if you want to get multiple printers, you have to be price conscious. And so again, some people prefer the mounted prices just because they can get more for the budget that they have. So, but there are various 3D printer options out there. There are probably 30 different 3D printing companies out here, but these are the three I recommend most often. So it's great you have a 3D printer. You have 3D printed objects, you want to use it, you want to be able to create great things. But again, it all goes back to, you need to have something to print. And the real skill when you're doing 3D printing and 3D modeling is not just, plugging in the USB and pushing print. It's actually 3D modeling an object. This is where the skill is. This is where you have your NASA professionals and your computer science people whose only job are to 3D model things, whether it's the next rocket that NASA's sending to the moon, or whether it's a new model of house, because architects use 3D printers. Video game designers use 3D models because they have to design the characters. They have to design the landscapes they're in. They have to use 3D modeling software to create all those things. Now, the software might be different than what you would use, like to say, with a 3D printer, but it's still 3D modeling. So the real skill is with 3D modeling. It's not with, 3D printing. And just because you 3D modeled something doesn't mean your end goal is to 3D print it. So that's one of those key distinctions that always has to be made and is often misunderstood. So 3D modeling can be done with multiple types of software. And each of these software, which we'll go into a second, is intended to be used with a different type of just application. Again, if it's a 3D printer, you're going to use probably a specific type of software that you can export and then slice. If it's for video game design, you need to be able to use it to create the characters, the sprites, the expressions, those real human type, features, eyes and all the stuff that you might not, the detail you might not be able to get in other types. If you're using it in architecture, you may need to have different built-in custom features in order to build the structures and be able to see it with all the different types of flooring, or maybe the types of paint or the types of roofing you have. Architecture is one of the oldest professions that has used 3D modeling, and it's one of the most commonly used. If you've ever watched HGTV and you see the models where they go around the house and they spin through and they see all the rooms, they designed that in a 3D modeler. So somebody had to make that, and it's probably someone's job solely just to make that 3D model of that house or that redesign they're doing. It's a huge industry. And then engineers use 3D modelers all the time, because if you are saying building a component for the Antares rocket, I'm just going to use as an example, and you want to test it out before you actually put it in the rocket, well, you can actually use 3D modelers such as Autodesk, put it in there if you're an engineer, and expose it to a simulated, heat field or a simulated force field. All right, we're going to put this nut here under 10,000 foot-pounds of pressure, and we're going to see if it's going to stay together. If it does, great. If it doesn't, we need to redesign that. And it's a good thing that we figured that out on a 3D model on the computer, as opposed to putting it in the rocket and testing it that way and having the whole thing blow up on us. So again, 3D modeling, especially for engineers, is a huge skill. If you've ever heard of the program called Project Lead the Way, that starts in middle school, it goes through high school, the youth that are involved in that have to learn 3D modeling as part of that program. So they usually learn Autodesk, which is one of the 3D modeling software out there. So Autodesk is probably the most commonly used 3D modeler out there. It's the one which, if kids in high school and they want to pursue engineering, I'd be like, yep, that's where you go. There's a couple of different types of Autodesk 3D modelers out there. They're all, basically PC based and can do simulations, and they're the professional grade. There's another one called SolidWorks. And again, this is just to kind of give you that background of, again, what the path is, what kids that are interested in this, where they can go. So Autodesk Professional. SketchUp is the one I mentioned earlier that oftentimes architects use. And again, HGTV, those models you see, if you've ever seen them, are made in SketchUp. So you can see the different room designs and the remodels. I mentioned earlier about the graphic design, the video game production, character design. Blender is very popular. These are all, well, these are all free for educators and students. Autodesk, if you're an engineer, costs a lot of money. But if you're an educator and you have youth, these are free to use in the classroom. You just have to create an account with them. So Blender is very popular with kids that are interested in video game design and animation. But again, it's a 3D modeler, same as the others. The one that we are going to look into the most today is Tinkercad, which is specifically the one recommended for beginners, for young kids, and in general, just for anybody new to 3D modeling. Because number one, it's browser-based, so you don't need to download anything. You can run it in Google Chrome, you can run it in Firefox. 2, it's free. 3, and one of the most important things, it auto-saves every single file you make the whole time. Mr. Mark, I forgot to save my file and I lost all my work. I can't help you, Katie. You don't have that problem with Tinkercad. It saves at every single step along the way. There is no work lost. It is a huge headache saver when you don't have to worry of whether the kid will be constantly saving it all the time or whoever it is. All these other programs, Blender, SketchUp, Autodesk, you have to download it to the computer. And just like anything, if you ever worked with Scratch or any other programs, it's the same, or Mindstorm's the same kind of thing. If you're not constantly saving, you risk losing it. So Tinkercad, you don't have that problem. So I've jumbled it up enough. I'm going to jump into Tinkercad. So first of all, just some ideas of some different things. Cell phone case. I'm going to go into Tinkercad here in a second, show you some things I've done. Simple design, actually. These characters are from the game called Among Us, which is very popular with kids these days. Kids like to make, animations or models of characters they might know in video games or TV shows. That's one example right there. They can do that in Tinkercad. And there's also another website I'll show you called Thingiverse that will allow you to also be able to take some already existing models. So I'm going to jump into Tinkercad, which means let me stop sharing this and let me jump to that other website, which is going to take me a moment because I have 15 screens up. Pause screen, new share. There we go. Okay. So Tinkercad, as I said, is a browser-based website. So it's free to sign up. If the child is under 13, they need to basically get parental permission, usually over email. But over the years, I've created a lot of stuff. What I'm wearing on my neck right now are 3D printed 4H clover necklaces. Very simple design. This is actually another variation of it. I made this totally in Tinkercad. So what happened? I was able to take the 4H clover that I found online. I was able to take the 4H sort of what I call the cool emblem, place it on top of it. And then using the text feature in Tinkercad, I was able to cut in the USC designation, which is very important. We need to make sure we have.
Hey, Mark, real quick, you might want to share another screen. There it is. Yep, there we go.
There it is. Okay.
Yes.
My apologies.
Nope, no, it's all good.
There we go. I'll back up. I'll just back up again and kind of start that again. So I've created a lot of models on Tinkercad over the years, lots of different purposes, trophies, displays, even like little things like jewelry. What I said before is, again, what I'm wearing on my necklace, or what I'm wearing here is basically very, very similar to, where did it go? Oh, it's right here. This design right here. This is pretty much the same design as I'm wearing right now. I've 3D printed it and I chose the color I want, that bright neon green. But this is the model that was created. So I had the 4H clover, got it online. I was able to put 4H on it, and then I was able to use the text feature and cut it into the clover so we have the USC designation. And so this is very, very simple to do actually in Tinkercad once you get to know it. In Tinkercad, like a lot of programs, the more you play with it, the more you do different types of projects with it and create different things, the better you get at it. So it's one of those things where you start simple, and then as time goes on, you progressively work to more difficult designs. That's how it all goes. But here's the basics of just how Tinkercad just looks. And again, the simple idea is just that there's a bunch of shapes on the right, They have different types of things you can scribble, text, stars, hearts, different just types of things that you can pull out and you just drag and drop. You can change the sizes of things however you need to. You can change the view that you're looking at so you can make sure it looks correct at all your different angles. By the way, that little hole there, that's what you thread your strand through, your rope, your yarn, your chain, whatever it is. So you have to just cut a little hole in there at a point. Not a difficult thing to do. There are some 3D modelers in which cutting a hole like that into it would be difficult. It's a very simple process in Tinkercad. So you basically drag a model, you change the size as you want it to, change the position however you want to, and then it changes and, immediately. And again, every single, change you make, it's automatically saved. So no worries about losing anything. Then you can put things together. So let's say, I don't know, let's say I wanted to cut a big hole right in the middle here. Well, I can take this box I created, I can turn it into a hole, which makes it transparent. And then I can group the things together and it will cut a hole into that model. Let's say I needed a bigger chain. And again, I did that very quickly. I've done this for 8 years. So the more you do it, the quicker you get. But the basic idea is, again, you're combining shapes, you're cutting, and you're merging objects together in order to create your desired outcome. Text. Let's say the kids want to make a name tag. Very, very common type of 3D model. They can make their own name tags. I'll actually show you one a little bit later. They also have all sorts of different types of shapes. These are just basic shapes. They have, let's see, where are they? Basic shapes, shape library. They have custom shapes. They have already pre-existing shapes, humanoids, dinosaurs, things like that. I'm looking for is shape generators. There we are. They have different types of houses. There are literally, I would say, thousands of different types of shapes that Tinkercad has pre-built into the program that you can just drag out, draw out, and kids can use to expand and go up and down and change however they want. It's just literally almost one of those things where they just kind of got to go searching around and see what strikes them, what fancies their imagination, and say, oh, that looks cool, or that's what I want to do, and let their imagination roll and then have them create it. And the other nice thing is that it's very easy to fix mistakes in Tinkercad. You just undo a bunch and it's gone. So it also makes it easy for kids to just, if they mess up, to fix it. So Tinkercad basically is a very user-friendly program. Here's another model. This is supposed to kind of look like a city, but this is actually what I created during the 4-H STEM Summit last year as sort of a model of what a base camp on Mars could look like. I did not create any of these shapes myself. These are all shapes. Like, for example, there's a solar panel here. I'm going to ungroup this just a little bit so you can see this. There's a solar panel here. That's a Tinkercad model. There's like different orbs. There's different spheres here. These are all built-in pieces to in Tinkercad. There's a satellite dish here. These are all models that already exist in Tinkercad. So I didn't have to create each of these things. When a kid is new to Tinkercad, or when anybody's new to Tinkercad, really, the whole idea is that you want them to start thinking three-dimensionally. How does the placement of objects in X, Y, and Z specifically relate to each other? Is this model in the correct position compared to the solar panel? It's starting to get that idea of measurement. Most 3D modelers measure things in meters or millimeters, the metric system. So 3D modeling is often used to teach applications of measurement. If this is, say, too close to the solar panel, I can simply move it away until it is correct. Or maybe if I need it a specific distance away from, say, the edge. Right now, this 3D modeler, the Tinkercad, is saying it's 77.85 millimeters away from the far edge. Let's say I need it to be 80 millimeters away. I'm going to change it to 80, and there it goes. As a tool to teach measurement, 3D modeling can be very, very useful. It gets the kids, it gets people that are new to the program thinking about, okay, how big do I need this to be? How far away does this component need to be from that component? Those are the critical measurement and mathematical skills that engineers need, first of all, when designing anything, but that the 3D modelers need when they're making their object or product. So we basically had at the STEM Summit in November, we had youth create their own 3D models of what they thought a Mars base camp would look like. And they completed it in about an hour. And we had quite a few variations in designs. A lot of them came out really, really well. And you'd be surprised, or a lot of them, it's their first time and they were able to create something in 1 hour. No, was it necessarily complex? Was it huge? No, but they were able to create something. And that's the important part. They were able to achieve some end goal. It looked a little bit something like what their imagination had in mind. If they spent more time with it, they could make it even better. And that's, again, one of those things that when I teach 3D modeling, I always tell is that the quality of the final product is always dependent on the amount of time you put into it. Is it not right yet? Okay, well, refine it more, make it better. Is it good enough? Okay, that's great. So I just finished. So the 3D cookie cutter just finished. There's a little bit of stranding to it, but literally, yes, it's supposed to be the Eiffel Tower. And yes, it has the edges on there that you can use to actually cut into the cookie and make it in the shape of an Eiffel Tower. So there's just one cute little 2 workshop idea you could do in the future, maybe around Christmas time or whenever you want. Create your own cookie cutter, create your own Christmas ornaments. If you could actually hang this from a tree, I think pretty easily, you just wrap the string around and then you're good to go. But that's something that a 6-year-old created in one of my workshops. So not a difficult design, basically kind of a curvy triangle.
Hey, Mark, how long did that take you when you started that print on the clover? How long did that take you?
The clover?
Yeah, the clover.
20 minutes.
20 minutes. So yeah, that's not bad at all. And we had one other quick question in the chat.
Yeah, I'm sorry, I haven't been able to see chat, so go ahead.
Yeah, no worries. Do you have a series of 3D prints that you introduce different concepts like adding text, cutting a hole, those kind of things? And then how many concepts before you turn them loose?
Yes, good question. So really, I should probably talk about this now before I go even forward. One of the other great things about Tinkercad and why I recommend it is that it has its own built-in lessons. When a person creates a Tinkercad account for the first time, the program immediately takes them to a series of lessons that it calls learning the moves. So let me find it where they just recently, there it is. So learning the moves is basically Tinkercad's way of introducing the program and that whole process of 3D modeling to first timers. So these are called starting lessons. And if a person has never logged on to Tinkercad before, this, the learning the moves sequence will pop up. And this is really nice because it literally takes them step by step by step about everything that needs to be done. So I'm going to back this up here a little bit so we can see it, if it cooperates. So what would happen? You boot up Tinkercad, you create an account for the first time, you log in, and it's going to prompt you and say, do you want to start learning the moves? When you see that, you click yes. This is the first lesson it will take you to. It's called Place It. I like this process because number one, it gives step-by-step instructions with visuals on the left and your work plane and everything else looks the same. If you're working on a 3D model normally, this wouldn't be here, but for the lessons, yes, it's right here. And it takes them piece by piece through what to do. So you see the orange shape on the work plane? Yes, I do. That's a hint, right? Find the box shape in the shapes panel on the right side of the screen. Oh, that says box. Left click and drag the box to the orange shape. Oh, doesn't line up completely. Boom, lines up completely. Next, done. Did it. All right. Next lesson. This is called viewing it. So this is about how they can see the different visuals, how you can look at it from different perspectives. So you can click the box and you can view this object from different angles. And again, if you're trying to teach 3D visualization in its three-dimensional design, one of the big perspectives, it's called orthographic viewing, is that you need to make sure that the model or that what you're looking at is correct or what you expect from all three directions. So you look at it from the X, from the Y, from the Z, maybe you look at it from an angle so that it all looks like how you want it to. You can then also move with the mouse itself, with the right mouse button. You can scroll in or scroll out in order to see finer detail. And then the other nice thing about Tinkercad, because this is not always the case in all 3D modelers, you have this work plane, the base. I always tell the kids first thing, assume the work plane is the ground. So it's the bottom, it's the base of the 3D printer, or it's the ground. So if this is supposed to be our real world, then if the 3D printer is printing this, like we just saw, it's going to have to start at the bottom of this model and work its way up until it's done. Okay. But in the real world, there's this little thing called gravity that can cause problems. So if I'm going to drag a block out here, and then I say, okay, I'm going to kind of stack these on top of each other. Ooh, well, there's a bit of a space there. So is the 3D printer, for example, is that an accurate model? Is that model correct? No. You have an object floating in the air. I mean, if you look at it from this perspective, yeah, that looks right. If you look at it from this perspective, oh, there's a hole. Oh, there's a hole. Well, let's say I were to then connect them. Okay, they're connected now. But wait, there's still a problem. You have this whole piece hanging out here. So again, if a 3D printer or some sort of design, manufacturing device is trying to make this thing and it's building it from the bottom up, it's going to reach here and it's going to be trying to print this thing on air. It's not going to work. It's going to create what we call sag. And so your block is going to kind of, by the end of it all, look probably something like that, like this. Because it's literally had nothing to build on top of, and so it's created sag. So if that's not what you want, then you have to provide some sort of support there. So it's always what I like to call the gravity check. Have you checked if gravity is there? Have you accounted for that correctly? Are supports needed somewhere? It's those kinds of things, translating computer models, computer images into real world constructs. That sometimes can be difficult, but then the kids usually are like, oh, okay. And they realize, and then as time goes on, they get better and better about designing things, with that in mind. And again, it's an iterative process. The more they do it, the more time they spend, the better they get. But anyhow, so going back to learning the moves, it takes you through step by step by step all the different parts of 3D modeling using Tinkercad. How to place things, how to view things, how to move objects. So I'm going to place objects around here. And by the way, Tinkercad is tablet compatible. So touchscreen compatible. So it doesn't necessarily need a laptop or computer. I know that Android tablets, it works. There are some iPhone tablets that I know work. It just depends more on the browser than the tablet. So, but yeah, basically the learning the moves does a lot of the teaching for you, a lot of the basics that just sometimes can be hard to put into words. Sometimes it's hard to do without actually doing it for them. It actually takes it through step by step and says, hey, here's how all these basic functions work. They're critical functions. They need to be done, but it has the kids do it themselves instead of you showing them, which to me is a much better way of teaching it. So there are about 8 or 9 learning the moves lessons. They can be gone through in about an hour, even less possibly. So if it's your first time at Tinkercad too, one of the first things I would do is to take that time and actually go through learning the lessons piece by piece, one by one. So I kind of got off tangent there, Dave, and I ended up going into another thing, but the learning the moves is really important. So I wanted to make sure that we talked about that. Are there more questions in the chat?
I've been able to keep up with most of them. One question for people that are still, and even in the future post-COVID, wanting to teach this online, how effective have you found it? Do you find it's easier to set up the Tinker classroom and monitor everyone's progress online that way? Or is it easier just to give the intro instructions and let kids design and troubleshoot on their own and asking questions of the instructor? How do you find like teaching online and using Tinker Classroom or not using Tinker Classroom works best?
I've honestly used both. By default, I actually, and this is one of those things, again, talking from the perspective of someone who's done it a long time. I don't usually use Tinker Classroom now. Usually it's a basic, I give the introduction and then I talk through, hey, we're going to go through learning the moves. And then I sort of just, go step by step, or basically module by module, lesson by lesson with them, and then so that we're all on the same page so that they go through it. Virtually, it works just fine, I believe. And most of the time, the kids tend to be very tech savvy. So, things such as this basically click the mouse and move it here. Don't really need to do that. A lot of people do use the built-in Tinkercad classroom feature. And it's fine. And yes, you can track progress directly that way. If you have a lot of kids, I just find that it becomes a little unwieldy, trying to keep track of all of them at once, as opposed to let me know if you have questions or let me know if you need me to look at something in particular, just because you have 20 or 25 models you're trying to look at once, for example, that can become, kind of, difficult to find the one you need and then to be like, what's going on with it, or just keeping track of everything at once. So by default, I don't usually use it, but there's a lot of educators I know that do.
Excellent, thanks. And I know some of our 4-H project leaders, what they do is they don't use Tinker Classroom, but then they have the youths participating send them the file. Typically, we don't have enough printers at the time, so we'll kind of outsource the printing after the fact. And so we'll send them the file, and that will give you a chance to tweak anything that might be a little bit off if you needed to as well before printing.
That's an excellent point to bring up, Dave, because if your intention, and this is the thing, I don't want to make it seem that you need the 3D printers to do a 3D modeling activity. That's probably the biggest misconception. The real skill, again, is 3D modeling. If you don't have 3D printers, don't think that learning 3D modeling is not worth it. It absolutely is. The 3D printing itself is really a bonus. If you have them, they're great. And it also allows an extra layer of what I would call modification. And again, the engineering design process. You've designed something, it's built it. Once you've built it, then you look at it. Okay, does it fill the purpose? Great. Does it not? Refine it. So it allows an extra layer, but it's not needed. So if you do have it though, I never print anything while I'm doing the session with the 3D modeling and teaching the kids. I do the 3D modeling afterwards, offline. So, because like Dave said, sometimes there are things you missed, so I'll look at a model, and if I'm looking at the sheet here and it's like, oh, there's a little bit of a gap there, I need to make sure that, I need to put something there. That's something that I can do real quick. And it's a lot, and that way I don't waste the kids' time doing that. And then I can slice it and send it to the 3D printer and do all that other stuff I'll talk about shortly. But I never really do the 3D printing when the kids are there because of the time involved And just because, again, the process then of taking the 3D model and putting it on the 3D printer and getting it starting to print takes a few minutes. You know, the kids love to see it. So if you have a 3D printer running while this is going on so the kids can see it, you know, that's awesome. But I don't start their 3D prints when I'm usually with them. That takes place over time. And then once it's done, if I see them again, that's when I give it to them, or I put it in an envelope and I mail it to them. We got any other questions, Dave?
Just one question that I've found, people want to know if you don't have a 3D printer. I found companies online and locally, and at the other source, libraries often will let you 3D print as well. Libraries tend to be the most affordable. Have you found any other sources for 3D printing projects if you don't have a printer?
The libraries are the big one these days. A lot of libraries have gotten some grants to get some 3D printers. Before I was with 4-H, I worked for my county library system, and 3D printing and robotics were my two big programs. Yeah, so the libraries oftentimes, sometimes they charge a little bit of money, sometimes they don't charge anything. So I would check, first of all, yes, with your local library system if you don't have a 3D printer. The other thing I would look into is to look up in your area if there are any maker spaces. So if you're living in, I don't know, if you're living in Wheeling, West Virginia, Wheeling, or let's figure something out. I don't know, wherever your town is, wherever the nearest city is, look up if there's any maker spaces nearby. They don't necessarily need to be youth maker spaces, but look them up. And if you ask them, because they're almost assuredly probably going to have a 3D printer, or they're going to know somebody who has a 3D printer, and say, hey, I have this 4-H club. We're 3D modeling and we have, say, a dozen 3D prints that we'd like to do. They're, you know, they're no bigger than X by X by X size. Is it something you're able to do? And in my experience, maker spaces tend to be pretty generous with that, because they kind of see it as, hey, this is kind of a generous donation thing. This will help get us, you know, a little bit more public support, maybe connect us with this group. Sometimes the maker spaces themselves offer 3D modeling sessions, but it's oftentimes on your more advanced ones. It's not usually Tinkercad. So the maker spaces, though, are oftentimes an option. And if they do charge, in my experience, it's not much. The thing about 3D printing and the filament, like if I use the Eiffel Tower as an example, the actual material that this print took probably was about 10 to 15 cents was the actual cost of this material. Now, of course, the printer itself is more expensive, but in terms of the material, especially if it's PLA, I just dropped it, but it's very cheap. A standard spool of 3D printer, this is Zealtech, available on Amazon. 3D printer filament you can get on Amazon very easily. This big 1 kilogram spool cost 20 bucks. You can get 3D filaments, 3D filaments sometimes as cheap as $10 or $15. Your exotics, so the ones I mentioned before, like the wood infused or the metal infused, the wood, the carbon fiber, or maybe if it's something fancy, like if it's a color changing filament, or if it's a very shiny specialty filament, yes, they can go more expensive. But the other reason I suggest PLA is just that the prices are so much more affordable. And as a result, if you're printing like 10 Eiffel Towers and they're like 15 cents a piece, well, you just spent $2 maybe. That's most of the reason why the maker spaces really don't tend to charge, because it's only a couple of bucks.
And I will say that's, as you look for options for 3D printing, the PLA is the most important thing, because you may find a really inexpensive 3D printer, but then the PLA becomes proprietary, and that's kind of like your printers, where it's like, man, it costs half as much to get a spool of the PLA that you need for that 3D printer as it did the printer itself. So just be very careful that you get something that's a little more expensive, but can take just that stuff you get off Amazon for cheap. That's definitely a buyer beware. I think they're becoming less common, but early on, that was a challenge that some of our 4-H groups ran into.
That's exactly right. And that's also why I recommend Monoprice and Prusa, because yeah, you don't have that issue. they take, as long as it's the correct size, 1.75 millimeter filament, yes, the brand of it does not matter. And actually, when I go back, I make a little note in the presentation. FlashForge, which is a common one that people get, their filament and all that kind of thing is proprietary. However, the website that I link to that you can get that FlashForge model I recommend, the people that sell it, they're a makerspace. They actually include a special add-on that makes it so the filament that you can use no longer is just a proprietary. It's basically a spool add-on arm. And basically it makes it so you can use any type of filament, and they include it for free. So it takes away exactly that issue that Dave was talking about, because yes, originally that was a big issue that a lot of people ran into. Thankfully, it's over time going away. FlashForge is one of the holdouts at this point, but most of the other ones, yeah, the proprietary stuff is no longer an issue.
And yeah, somebody put in the comment, libraries with lots of high schools have 3D, or high school libraries have 3D printers. Yeah, they will. And that's the thing, is it's all about building your network. Similar way that back in the day, you'd find your county GIS that had the large format printer that you could print off 4H GIS maps for. That's what you're going to do, is look for that network of people that have 3D printers, and they keep coming down in price. That's what's exciting, is they are more and more affordable as we go on. But again, I don't want to emphasize that like that's the end all be all. What Mark talked about and was so important is the fact that it's the 3D modeling. Like, we didn't intend for anybody to print out their entire Mars base camp in 3D, because that would be really expensive and take a lot of time. But then it's a really cool skill that they have to showcase what their base camp looked like and share their ideas with others.
So I want to show 3 different basic, ideas for things you can do in Tinkercad, Dave, real quick. I just want to make sure there's no other questions first before I do that.
Nope, no other questions so far.
Okay. So one of the other questions I get all the time is, okay, I want to teach 3D modeling, but I don't know what kind of limitations or projects that I want to be able to do with the kids, for their first model. Valid question. So I'm going to show you 3. Whoops, and my computer got mean again. There we go. The first one I'm going to show you is a simple name tag. So it's the one I actually just had up a minute ago, and where did it go? Oh, right there. Okay. So this is a really simple design, and it's one of the reasons that I always push for something like this. So what is this? If you were to ask a kid, okay, what is a name tag? What does a name tag look like? They'd be like, oh, it has my name on it and all that kind of thing. It's like, okay, that's great. What about the shape? Then you start getting them thinking, well, the shape is like a rectangle. Okay. Is it a thick rectangle? Is it a thin rectangle? No, thin. Okay. All right. How do you place the letters on it? Are the letters just no, the letters are centered. Okay. Well, what's your name? Well, if your name's John, then John needs to be the biggest thing on there, right? If there's a little logo or something, you can put that on there, but then you all have to have it all centered. And then you start having to say, okay, is John like sticking out? Is it kind of maybe set in? Is it cut into the thing? And you start having the kids realize, oh, this name tag actually has more things going on with it than I thought. In terms of 3D modeling, it's a very simple design, but you have to know what each of those elements are first if you're going to design it. So this is a very simple, again, 3D model. It has a 4H clover, so if there is some logo or design, it can be on there, but it doesn't actually really need to. So I'm just going to, those are all just little pieces that are part of the clover. I'll just get rid of. Here's a basic 3D name tag. So what is it? You have this rectangle. How do you make the rectangle? You bring out the box, you squish it, you make it the size you want. Great, wonderful. Okay. Now, you need to put text on there. And actually, I'm going to move this to the side and I'm going to create this. And again, I'm jumping through this very, very quickly, but only because, I want to make sure that, it's just a overview of some things. So name tag. Okay. Well, then I want to put my name on it. Okay. Go there. I'm going to type Mark. Okay, wonderful. Oops, that's not centered. Oh, that sticks out pretty far. Well, again, that might be difficult to fix in some of the other 3D modelers. With Tinkercad, you just have to click the white boxes and then shrink it as much as you need. Yeah, it looks about right. But it doesn't look centered. Math. So if this rectangle is currently, we're just going to make round numbers here to make this simple. 100 by 50. My name, we're just going to, again, make numbers round. But can you already start seeing where you can start doing some of the math with them? This is an application of math in real world. So this box is 100. My name is 75. So you have to take the difference between the two. 100 minus 75 is 25. But then you need to have it balanced on the left and the right. So you have to do 25 divided by 2, which is 12.5. Okay, I'm just turning off the limits there. So that means that my name has to be 12.5 millimeters from the edge. So I would come down here and put in specifically 12.5. You also have to make sure, of course, that your box is in the right position and that you're starting at the right points too. So here, there. Yeah. So my name now is centered left to right, but it's not really centered at the top. So my name is now 20 millimeters tall, or I guess long, you can say. The actual rectangle is 50. So you did the same thing. 50 minus 20 is 30. You want it centered top and bottom, so you divide by 2, so it's 15. So I need to have my name 15 millimeters above. Oh, but it's a little low because the box is actually not right at the origin. The origin in Tinkercad is that little circle. So it's about, so the actual rectangle is 8 millimeters above the origin. So what I actually need to do is add 8 to my 15. My name is officially centered.
So Mark, can you, the question was, can you just drag the lettering over in Tinkercad, or do you have to adjust the math?
You can do the dragging. You absolutely can. If you wanted to teach the math, you could do it. But yes, if the kid was so inclined, or you were so inclined, yeah, you can just kind of eyeball it and boom. Close enough. It all depends on what your goal is. If you're just trying to get them to do it, or if you're trying to teach the math in it, whatever you're preferring. Yeah, you can otherwise, yeah, you can just have them drag and do it that way. The math might be a little bit complex depending on the audience you're doing, but it is basically just arithmetic. Add, subtract, divide. But yes, you can, but that's the other great thing about Tinkercad. You can do it the mathy way, or you can do it the drag visual way.
Okay, any other questions for Mark before we wrap it up here? Mark, do you have a slide with your contact? Because I know there's going to be some email questions that might come out later.
Yeah, so let me actually stop sharing here for a sec. I can't even see the clock on here right now. My Zoom is not cooperating with me today at all. There we go. Yes, contact info. Always available by email. Let me jump through and get to the just some of the links. And again, this PowerPoint will be shared. This is a PowerPoint I've done many times, and so it's okay. Here are the resources. I hope you all can actually, I have to reshare my screen. But basically, it has where all the different, has the links to where you can get some of the 3D printers. It has the links to some documents I've created that could be useful. Can you see this resource page, Dave?
Nope, not yet, no.
Oh boy, come on, Zoom. Cooperate with me just a little bit longer. Hey, hopefully that's it. So it has the Prusa website, it has FlashForge, it has the Monoprice website, and it has some documents I have created, such as the summary of your 3D modelers. just basically your prep guide for Tinkercad, some general tips and tricks. And then I have a document that's basically a bunch of videos on YouTube about applications for 3D printing, including some of the ones we discussed. So those are all available. And once this is shared, Gabby will share it. It should include that, so you all can use that however you want.
Excellent. So a huge shout out to Mark for doing this. And as he mentioned, his email's in the chat, and we will share the recording and his PowerPoint so you have all the resources because they are valuable. And Mark honestly is the guru of 3D printing and 4-H. He makes it fun and easy for all of us. So we appreciate everyone joining, and especially Mark for sharing his expertise.
Thank you, Dave. And just one real quick plug is that if you haven't heard about the 4-H STEM Symposium, to register for that, and I can put a link to chat, but I also see some people wanting me to put the links back. So let me just do that real quick. There, hopefully you can see the links. Let me get the STEM Symposium link up in the meanwhile, so you hopefully can see that too. But the 4-H STEM Symposium is happening in May, and I think registration might actually close today. So great opportunity for, if you're interested in STEM and just a collaboration and learn what's going on out nationwide in the STEM world. So let's see. Can you still see the links? I'm trying to find the STEM Symposium link, that's all.
Of creating a bundle of things. Yeah. Okay. Well, thank you for taking that back, Mandy. I really appreciate it. And Gabby, thanks for having the conversation today.
I'm glad it was useful for people. And again, I get a lot of people just ask me just general questions. So don't hesitate to email me. I like talking about it. If that wasn't obvious, I like 3D printing. So I love talking about it. I like sharing just the idea, and I hope to get other people passionate about it because I do think it's something we're going to see more and more of in the future. Mm-hmm. Hey, I finally got the link.
Thank you. And I was just going to repeat that you don't feel free to share anything that is missing to me, and I'll share it to everyone else that registered as well. Again.
So I just put the STEM Symposium in the chat, and get rid of that. That's something else entirely. Whoops, you might have gotten a view of my email. I hope not, but but yeah, these links will be in the PowerPoint that Gabby will share. Do I need to copy it into any of the links into the chat in particular, you think?
No, I didn't see any specific requests for that, but
Okay.
I'm going to send, once you share it, I'm going to send the actual as a PDF picture for everyone so they can grab all those links directly.
Got it.
And I wanted to say, I saw a question in the chat about someone saying they missed the other 2 workshops before this one. We are working on getting it put up on our Click to Science resource, which you'll be hearing more about in the future. So these will be living somewhere in the future for a kind of a permanent stay. But I'm also in the meantime trying to put together a Google folder that you can access in the meantime as well. So they will be in one place for you to access.
Gabby, I also have that folder of stuff, and it's an open folder. So I have some of the links in there, but I can share, but people can access that. And so it has multiple things in there if it helps.
Okay.
So I'll send it to you and Dave then.
Awesome, that's perfect.
That way people can just, get to it at their own time.
That's exactly it.
And by the way, this 4-H trophy, I can share some of these models too, as well, that I've created. They're helpful as well. So I'll try and throw that in the show. There might be 100 links by the time we're done. That's just how it goes, I guess.
That's okay. That is just okay.
I appreciate the feedback though, and I'm glad everybody got something out of it.
Are there any other questions? If not, I will let everyone go. Thank you very much again, Mark, for your time today. This was wonderful. I know a lot of people got a lot of this, so I'm glad to share this with everyone. Awesome.
Yeah. Just let me know if you need anything from me, and I hope you all have a great rest of your week and good luck with the 3D printing.
Awesome, and continue to save your date. We have our next one in May, so watch your emails. We'll be sharing out information on the next webinar in this series. Take care, everyone. Bye.